Okay, so JTM30 Marshall. This video is basically going to document what I had to do to get this thing up and running. I got it in non-functioning state, pretty cheap. It would power on, and the light would come on here, and the actual clean dirty light, LED light would come on as well, but no sound whatsoever. I got it from a guy who said it just stopped working one day. He put new tubes in it, still nothing. So that's basically what I started with, an amp that did not, totally non-functioning really. That's where it began. So what I do? Well, first I did some research online and realized this is a very bizarre, well, for a number of reasons, a bizarre bias circuit, which is fixed, not adjustable, which is part of the problem why these things melt down, because they're way too hot from the factory. So there was a bizarre bias pot that was added to this one. You can see it's adjustable here with a little screwdriver. It was in the chassis and here, and you know, somebody drilled a hole where you could adjust it in theory. Now, when I looked at how this was actually wired into the circuit, I don't believe that it was actually adjusting the bias. So I pulled it out, put it back to stock as much as possible. A little bit more on that in a second. So getting it back to stock involves you're dealing with a bias circuit that is dealing with Zener diodes, which are not normal diodes. They run negative voltage through the whole bias circuit back here, and the problem is they're not adjustable. You have to unsolder them and solder in new ones if you want to change the bias. And if you keep the original Zener diodes, you're going to run way too hot. And probably most of these probably were red plating their power tubes. So here's the circuits. This is actually the section in here that we're talking about with the bias circuit. I had to pull out, somebody put like I said, a variable resistor in here in the middle slot where there was a Zener diode, or a Zener diode, and then put a normal diode in here as well. Not a Zener diode. They replaced one with a normal diode. Didn't make sense to me, so I pulled it out, put Zener diodes back in here, with the exception of changing the 9 volt to 15 volt, which will then lower the current going to the tube. So in addition to that, I replaced basically every electrolytic cap in this thing, which you can see here. These were all originally 85 degrees Celsius caps. I changed them with 105, better, higher heat resistance. There was also a preamp socket that had been replaced and kind of butchered. They put in a non PCB socket, and it was very hastily kind of wired in. That was pulled out, replaced with a correct one. Now, I have a feeling what happened with this is one of the tubes looked like this, right? Which this white caking in this tube, something happened inside of it. It shorted and probably got really hot. And I think that's what happened and ultimately caused this thing to die. Because really, or stop working, what really took me forever to figure out was the culprit of the thing not working at all. After I placed all the caps, fixed the bias circuit back to stock with a little bit different Zener diode, put power tubes in it. Power tubes were getting power, looked good. I could actually even check the bias on them, but I still had no sound. So something was wrong with the preamp side. What is that? Well, you can see in the circuit here, there's a rectifier, and it's this, I believe it's a BR62. It's a 6 amp rectifier that was dead. So no current got past this side over to the preamp tubes. I replaced it with an 8 amp actually. I couldn't get a 6 amp, so it's a little bit different size, but now everything works fine. My bias is actually kind of on the cool side now for this amp. I think one of my tubes is about 58%, the other one is about 49%. But for an amp that's known to get way too hot and melt down and have heat problems, that's not a bad situation to be in. So I think I'm gonna leave it like that and put it back together and do another little video. More to come.